डियर स्टूडेंट, गुड मॉर्निंग। लर्निंग आइलैंड यूट्यूब चैनल में आप सब लोगों को स्वागतम करता हूं। आज का टॉपिक्स है क्लास 12 फिजिक्स का चैप्टर 3 से MCQs which are very relevant for your monthly exam. So you can also go through the previous videos where you will get the MCQs from chapter 1 and chapter 2. So let us start without any delay. So chapter current electricity. The first question is, in how many different ways 1 ohm resistance can be combined? मतलब 1 ohm वैल्यू का 3 रेजिस्टेंस है, वो 3 रेजिस्टेंस को हम किस तरह से कंबाइन कर सकते हैं, दैट इज कॉम्बिनेशन हम कैसे कर सकते हैं. ओके, सो let us see how you can combine all these. You may arrange them in series, parallel, whatever. So options are this. Options are this. So the answer would be 4. Now the question is how. How? Let us discuss this, because without proper clarification you would not be able to understand. Okay, see, there are 3 resistance. Suppose this is 1, this is 2, this is 3. Suppose this is R equal to 1 ohm. This is also 1 ohm. This is also 1 ohm. So अभी इसको कंबाइन करना है सीरीज या पैरेलल. कैसे, कितने टाइप में कर सकते हैं? सी, इफ वी कनेक्ट देम डायरेक्टली, this is the series, this is one type. We can connect them like this. Suppose this is one resistance and connect them another with series, and the third one connect parallelly. This is type number 2. Now again we can connect all these 3 in parallel, so we can connect them parallelly. So this is also one type of combination. So this is 3. Now we can connect another type. Connect 2 resistor in parallel and third one in series. This is 4th type. So these 4 types of combination are possible. So answer is 4. Now let us go to the next question. Okay, hope you understand. Now question number 2. If 400 ohm resistance is made by adding 100 ohm resistances of tolerances 5%, then the tolerance of the combination is. Always mind that if the resistance are having 5% tolerance, then the combination would also be 5%. So the answer will be 5%. So it is, I think, easy questions, no need to explanation. Now moving forward. Okay, this is question number 3. Resistance N each of R ohm when connected in parallel give an equivalent resistance R. If these resistances were connected in series, the combination would have a resistance in ohm equal to. मतलब क्वेश्चन का मतलब समझ लो. Okay, let us see the options. Options are this. So to understand the question properly, see here they have mentioned that total n number of resistance when connected in series, when connected in parallel. Suppose these are one number, two number, three number, dot, n number of are connected parallelly. You know, this is a parallel circuit. If we connect them parallelly, the value of the resistance is small r, 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 dot, v. If you connect them parallelly, then total equivalent resistance becomes r. So here you can say r equal to r by n, because in parallel connection, equivalent resistance is like this. Number of resistor n, the value of each resistor r, so r divided by n. This is the value of r. So from here I can get small r equal to n into capital R. Now if they gets connected in series combination 1, 2, 3, dot n number. So this is small r, this is small r, this is small r, dot up to n. This is the series combination. So in series, we add up all the resistance connected to get the equivalent resistance. So here equivalent resistance would be R equivalent would be R plus R plus R plus dot up to n. Nth term. So this would be n into small r. So if you put the value of r here, n capital R. So n into nr, that is n square r. So is there any option like this? Yes, option A. So this would be the answer. Hope you understood this. So let us see the answer. So this is the answer. Now we will go to the next question. Before going to the next question, let us remove these drawings. Okay. Now next question. Question number 4. In the series combination of two or more than two resistors. In the series combination of two or more than two resistors, क्या होता है? The current through each resistance is same. The voltage through each resistance is same. Neither current nor voltage through each resistance is same. Option D, none of this. So आप जानते हैं सब लोग, जो सीरीज कॉम्बिनेशन होता है उसमें जितना भी रेजिस्टेंस हो, नो प्रॉब्लम, बट करंट रिमेन्स सेम. We know that. So no need to explain more. So this is the answer. The current through each resistance is same. And in case of parallel circuit or parallel combination, the voltage remains same. You know that. So let us go to the next question without a delay. If it is necessary to explain, I will explain. Okay. So let us go to the next question. The IV, this current versus voltage characteristics shown in the figure like this here. In the x direction, that is voltage, and y direction is current, and there is the graph. Now the option are this ohmic conductor, insulator, non-ohmic conductor. superconductor. Which type of conductor is it? See, in case of all you know that ohmic conductor, in case of ohmic conductor, that graph should be straight line. Okay, but here you see this is not a straight line, it's like this. So that means this is not a ohmic conductor. Okay, so it is not also an insulator, it is also not a superconductor. So the answer would be it is non-ohmic conductor. Now come to the question number 6. With increase in temperature, the conductivity of option A metal increase and semiconductor decrease. Is it correct? Let's see the option number B. Semiconductor increases and metal decreases. Option C. In both metal and semiconductor increases. Option D. In both metal and semiconductor decreases. Now, you see the answer is the semiconductor increases and the metal decreases. Okay, with increase in temperature, conductivity increases means resistance decreases. Conductivity decreases means resistance increases. So you see in case of metal, if you heat up a metal, suppose a wire of copper, then definitely its resistance increases, the metal. So resistance increases means its conductivity decreases. So here you see mentioned that conductivity decreases and for semiconductor it increases. So it is very clear to you. Let us go to the next question. So next question is, what is the suitable material for electrical fuse? Copper, constantan, tin lead alloy, nichrome. You know it is a tin lead alloy. जब भी बनाता है फ्यूज वायर जो कि घर पे यूज होता है कट ऑफ के लिए, सेफ्टी पर्पस के लिए, जिसका melting point very slow, very small, and also it's the rating current is very low, that is which is suitable for room. So in this case, tin lead alloy is used. So it is no need to explain it more. So let us go to the question number 8. Question number 8 is at temperature 0 degree K. At temperature 0 degree K, at temperature 0 degree K, the germanium behaves as, germanium is a semiconductor, you know, so it behaves as insulator. Here it is mistake, spelling mistake. It would be indulator, it would be insulator. Okay, so now the electric field intensity E. Question number 9. The electric field intensity E, current density J, and specific resistance K are related to each other through the relation E equal to J oblique K, E equal to JK, E equal to K by J, K equal to JE. So what would be the answer here? J is the current density. Okay. So here the answer with that relation, current density, answer would be E equal to JK. For this you will have to go through my another video where the relation is derived. So this is the relation. So no need to explain here now. Now let's go to the question number 10. Okay. Don't worry, I'm explaining the necessary points only. This kind of small thing, you know. So you might have, few students might have get annoyed that why sir is explaining all these things, small things. Okay. If you have any confusion, you may put your question in the description. I'll get you back. Okay. Now question number 10. For which of the following dependence of drift velocity Vd on electric field is Ohm's law? V varies E square, V varies e to the power half, Vd constant, V varies E. Which one is the answer? Here you see, there is a relationship I'm mentioning here. There is a relationship between Vd, that is drift velocity, equal to Ez by m. M is the mass of the electron, E is the charge in the electron, and capital E is the electric field, Z is the number of electrons. So here you see the number of electrons is the constant, M is the constant, E the charge in the electron is constant, small e. So all are constants, so I can write Bd varies as E. It's varies directly. Okay. It is proportional directly. So the answer would be like this. You see, the answer would be Vd varies as E. इलेक्ट्रिक फील्ड जितना बड़ा होगा उतना ही ड्रिफ्ट वेलोसिटी होंगे. Okay, understood? Let us proceed for the next question. The speed at which the current travels in conductor is equal to. Do you know that? Always mind it that the velocity of sound at vacuum or air is 3 into 10 to the power 8 meter per second. So in this case also it is same. So here the answer will be option B. Okay, so no need to explanation. I am going forward. Now let us first delete the previous drawing. Yes. Okay. Now the question is, in following figure shows current in a part of electrical circuit, then the value of the current in ampere is given by. See, here is Kirchhoff's current law. Okay. Look, Kirchhoff's point junction law, current junction law. So that is here it is a junction. I am showing you that is a junction, that is a junction, it is a junction, it is a junction. Kirchhoff says that the inward current and outward current at a junction is same. This is the inward current 3 ampere and 1.5 ampere are the inward current, and outward current is this one. This one is outward current. So inward current inward inward current here equal to 3 plus 1.5 ampere. So it will be 4.5 ampere. That will be equal to outward current. So here current moving is 4.5 ampere, and here in this junction inward current is 4.5 ampere, outward currents are 0.5 ampere and something here. So here it will be 4 ampere. Now from 4 ampere, 2.5 ampere is going outward, 4 ampere is inward for the junction. So in this direction, current moving would be 1.5 ampere. How? It is 4 minus 2.5. So it is 1.5. Now for this junction, 1.5 ampere is inward current. So 1.2 is going outward. So in this direction, I would be 1.5 minus 1.2. That is 0.3 ampere. So hope it is clear. Now let us see what is the answer given here. These are the option. So answer is 0.3 ampere. Okay, 0.3 ampere. I hope you got it. And now let us go to the Question number 13. If the length of conductor is halved, its resistance will be what? Half, doubled, unchanged, quadrupled. देखो ये आप लोग क्लास 10 में करके आए हो तो आई एम नॉट एक्सप्लेनिंग दिस okay, otherwise the video will get lengthy, longer. So let us see the answer. Halved. If the length of the conductor is half, its resistance will become half. Now 14. If the circuit potential difference between x and y is m, okay, let's see the option. Is your option? So the question is, let us understand the question first. Question समझने से 80% problem solved. If the potential difference between x and y means here the potential difference is m, and the voltage across 40 is n. 40 means here voltage in this point, the voltage b equal to n. Okay, n. Now therefore their values are, ये n और m क्या होगा? n का वैल्यू क्या है और m का वैल्यू क्या है? See, in this circuit the voltage applied is 120 and here internal resistance is 20 ohm and here is 40 ohm. So as this is a this is a open circuit, so there is no current flow. Okay, so if there is no current flow, then the voltage drop at 20 ohm and 40 ohm definitely zero because there is no current, because you know V equal to I into R. So resistance 40 but current is zero, so it will be zero. So here N would be zero, and as it is closed circuit, in the battery it is 120 voltage, so it is plus, it is minus. So 120 voltage will come here and here 0 would come here. So in this point M would be 120. In this point, see, X point is connected with this battery positive and Y is connected with this negative. So here voltage difference is that the potential is 120, so the same would come here. So M would be 120. So hope it is clear to you. Okay, so the answer would be 1 M 120 and N 0 voltage. Okay, hope this is clear to you. Okay, I'm again telling you, if you have any doubt, please put this in the description. I will get you back. Okay, so now let's go to the next question. Next question I'm going. Question number 15. Here you see again the Kirchhoff's law. Find the current I in the given network. So I'm not explaining right now. I'm directly giving you the answer here. So see, the answer options are this and the answer will be 1.7. You do it yourself. Okay, same principle I have discussed earlier. Now question number 16. The relation between drift velocity Vd and the intensity of electric field E is. I think this kind of question have been discussed earlier. So here I am again explaining. I think no need to explanations. These options are C. Vd is directly proportional to E. Yes, I have earlier told you this is the relation. Vd inversive no. Vd is proportional to E square no. Vd does not depends on E no. So answer would be Vd is directly proportional to E. जितना E बढ़ेगा Vd इतना बढ़ेगा, जितना E कमेगा घटेगा इतना Vd घटेगा. So now the next question is find the effective resistance between A and D. Here you see the value of R is 10 ohm. So options are this. So answer is 40. So how the answer come 40? Okay, just 1 minute. I'm going to the previous one. This. So answer is 40. How? See here, they asked कि पॉइंट ए एंड डी का बीच में रेजिस्टेंस क्या है। ये जो आर है सबका रेजिस्टेंस 10 ओम करके है। सो इफ आई ड्रॉ इट सिंपली द सर्किट बिकम्स लाइक दिस। ओके, circuit would become like this. This is D point, this is A point. Now here another resistance are there. Here, so these two resistance, that is point C, it is point B, this point C. So these are open, so they will not be come to the count. So here it is 10, here it is 10, here it is 10, here it is 10. Here also 10, here also 10. This B also 10, this C also 10. So as this B and C terminals are open, they will not come into the calculation. So here you see these two resistance are in series, okay, and these two are also series. So in series, the equivalent would be 10 plus 10, 20. Here also it will be 20. And again, these 20 resistance are in parallel circuit. So their equivalent resistance would be what? 20 by 2. So it would be 10. Okay. If 20 are in parallel circuit, so the equivalent resistance will be, what is the equivalent resistance? 1 by R equivalent equal to 1 by 20 plus 1 by 20. So there would be 1 plus 1, that is 2 by 20, it is 1 by 10. So equivalent here would be 10 ohm. So between A and B, 10 plus 10 plus 10, 30. So this answer would be not 40, this would be 30 ohm, okay. This written mistakenly 30, the answer would be 30, 40 is wrong. So I think you got it. So the answer would be 30 ohm. Now go to the next question. First of all, remove all this. Now come to the next question. The next question is, when n numbers of resistors are connected in parallel, the resultant is x ohms. If they are connected in series, the equivalent resistance would be. Okay, here this kind of question I have done, I think, earlier. This answer will be an n square x. How has this come? Let us discuss this. See, if numbers of connected in parallel, n numbers of resistance are connected in parallel. N number of resistors are connected in parallel. N number, n number, and the value of resistance of each, I don't know. Suppose this is R. Suppose this is R, small r, small r. So in case of parallel, the equivalent R equivalent, here it is mentioned X. So this would be equal to R by N. So R is coming N into X. If these are connected in series, the N number, all are R. So equivalent here would be R dash equal to r plus r plus r plus nth term will be n into r. Again, value of r is nx, so it will be n into x. It is n square x. So answer will be n square x. So hope this is clear to you. So let us go to the next question. So it is looking clumsy. Let us remove this previous drawing. So now you see the question is the graph between potential difference V and the current I drawn from the cell is shown. The EMF shown, the EMF and the internal resistance of the cell is, options are this. So you see, how will you find out this? This needs to be understood properly, otherwise you will not be able to give the answer. Let's see this graph. Voltage is shown in y direction and ampere is shown is x direction, 1, 2, 3, 4 ampere. Now, how will you find out the internal resistance? See, suppose this is an external resistance and this is the battery cell and this is the internal resistance of the battery. This is the outer resistance. So this means the battery. In battery को भी एक resistance होता है internal. We should count this also. So if this is the circuit, okay. If voltage V, if this is the EMF E, this is the internal resistance, and the voltage against this R is V. So this kind of combination, we have done this in 10th class also. So we can write here V equal to E minus I into R. If the current flow through circuit is I. So this is the equation. See this equation, if we compare with the equation y equal to mx plus c, where m is the slope of the curve in this kind of curve and x is the value of the resistance and c is the value of, this is compared to e and this is compared to r, okay. And mx, okay, mx plus c. So if you find this out from the equation, you will get r is the, see, I'm comparing it first of all. So here you see voltage is 2 and current is 5. So if I take this comparing this equation here, y equal to mx plus c, c is e, so c is the x, here c is value is the y intercepts. Y equal to mx plus c means, y equal to mx plus c means c is what? C is the y intercept. Y intercept means this. So here c would be equal to what? Here c would be equal to 2 volt, definitely. C is the E. Here C is equivalent to E. So E would be 2 volts. So here I think this and this may be the answer, because C we have got the E. Now let us check on the value of R. R would be, R is the slope. Where R is the slope. So slope means slope of this curve. So R would be equal to slope of this curve means x by, slope means x, here x by, x means 2 by 5. You know This is tan theta. So if it is theta, so tan theta will be perpendicular by base. So perpendicular is 0 to 2 and base is 5. So 2 by 5. That would be 0.4 ohm. So I think this is the 0.4 ohm. This is not. So the answer would be option C. Hope clear to you. Okay. So this is the answer. This is the answer. 5. Is it 5? No. This should be answer. Answer is a little bit wrong here. It should not be. So sorry for that. The answer would be. I'm writing down here. Answer would be here. It would be option C. 2 volt and 0.4 ohm. This is the answer. Okay. Now come to the next question. So the students, thank you very much for being with me. Please stay for another 5 minutes. The video will end up. So I hope you are getting benefited. If you really got benefited, please subscribe my channel and also share this video with your friends so that they can also get the benefit out of it. And now let us go to the next question. The resistance of a conductor is inversely proportional to, you know that. You know that. No need to explain this area of cross section. Yeah. How should I explain it? Because it is from your class 10 topics. Okay, you know, R variables rho L by A. R is equal to rho L by A. So here A is in the denominator. So you can say R varies inversely with cross section area. A is the cross section area. So hope this is clear. Let us go to the next question. Okay, the next question is the equivalent resistance of two resistors connected in parallel is 12 ohm. If one of the resistor is 18 ohm, the value of the other is. This is also a very easy question. Still, I am showing you the equivalent resistance of two resistors connected. See, two resistors are connected parallelly. Okay. Now, one is 12 ohm, another is don't know R. Okay. The equivalent resistance of a two resistors connected in parallel is 12 ohm. If one is one is not 12, one is 18, and another is don't know. And R equivalent is given. R equivalent is given how much? 18. So in case of parallel, we know that R equivalent equal to 1 by 18 plus 1 by R. Now you see it is given 1, it is 1 by 18, it is 12, not 18. R equivalent is 12, 12, 12. R equivalent is 12, just 1 minute. R equivalent. R equivalent is, see, the current resistors, the equivalent resistance is 12. So it will be 1 by 12. It is 12 equal to 1 by 18 plus 1 by R. So from here 1 by R equal to 1 by 12 minus 1 by 18 equal to 12 into 18, 18 minus 12 is coming 6, and here 1 2 into 1 by 18, 2, 1 by 36. Okay, so R would be 36 ohm. Is that an option? Yes, this is the answer. So hope you can pause the, if you are not being able to understand, if I am going very quickly, you can pause the video and understand it properly. Okay, so the answer would be 36 ohm. Okay, now come to the next question. The best conductor of the electricity is, it is known to you, I think. So it is silver. Okay, the next question. All good conductor have a high resistance, yeah, reluctance, yeah, conductance, yeah, impedance. You know this conductance. No need to explain. Now come to the question number 24. 20 million of electrons reaches from point X to point Y in 2 seconds as shown in the figure. Direction and magnitude of the current is. See, these are the options. You see, I need to explain it here. See, क्या बोला यहाँ पे? 20 million of electrons reaches from X to Y. X से Y, this is X, this is Y, okay? This is X, this is Y. X से Y की तरफ 20 million इलेक्ट्रॉन पूछ रहा है इन 2 सेकेंड में, तो क्या होगा? वी नो इलेक्ट्रॉन जिस तरफ जाता है करंट उसका ऑपोजिट में होता है, सो डेफिनेटली करंट वुड बी from y to x because electron is moving x to y, so current would be from y to x. It is clear. So in this option from x to y, from y to x, so the answer may be this one or maybe this one because the current direction is y to x. Now let us find the value of current. You know what is current? Current equal to q by t. Rate of flow of charge is current. So here 20 million, this is 20 0 0 0 0 0 ones, tens, 100, 1000, 10,000, million. Okay, so is it correct? Now it is 20 million. Okay, 20 million into 1 electron, 10, 1.6 into 10 to the power minus 19 divided by time. Time is 2 seconds. Okay, if we divide this 1, 1, 2, 3, 4, 5, 6, 7. So that is minus 19. So answer will be 1.6 into 10 to the power minus what? minus 19. यहाँ से 7 चल जाएगा तो 1 2 3 4 5 6 7 7 9 to 7 12. So it will be the power minus 6. How? Minus 12 to the power 10 to the power minus 12. Okay, 1.6 into 10 to the minus 12 minus 6. Just 1 minute. 19 and it would be 10 to the power 1.6 into the minus 6. See, 20 million, no? 20 million, huh? Okay. So it will be 1, 2, 3, 4, 5, 6, 7 into 10 to the minus 19. 7 is 12. 1.6 into the minus 12. Minus 12. Is there a figure like this? 12. So here the answer will be minus 13. Maybe just a minute, student. 1 million. It is 20 million. 20 million. You know, 10 lakh equal to 1 million. So 1, it is 20 million. Take it. So to beat 10 to the minus 12 actually. There is a little bit 20 million of electrons. 20 millions of electrons. One zero is coming here. Just I am doing it again because here it is a mismatch. Just 1 minute. Yeah, see. Let us start it from fast. So n equal to number of electron. Okay, equal to 20 million. Okay, so we know 1 million equal to 10 lakhs. 10 lakh means 1, 2, 3, 4, 5. 1, 10, 100, 1000, 10,000 lakhs. So 10 lakhs. So 20 million should be 1 million equal to 10 lakhs. So 20 million will be 20 into 10 lakhs. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 1, 2, 3, 6. Now it will be 2 into 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is the number of electrons. So the current flow is charge by time. So I can write it is charge here is charge, again we can write n into E. N is the number of electron, E is the charge of electron. So here the term is coming like this. N is 2, then 7, 0, 4, 5, 6, 7. Okay, into 1.6 into 10 to the power minus 19 coulomb by time. Time is 2 seconds. So if I divide this, finally it is coming, it is cancelled out. So it will be 1 into 1.6 into 10 to the power 7 0 minus, so it will be minus 12. So it is coming finally 1.6 into 10 to the power minus 12 ampere. Okay, so here a small correction needs to be done. It will be 2. Okay, this will be 2. So the answer will be C, option C. I think it is clear to you. Okay, okay, now comes to the point here. Let us see the answer. It is so in this answer it is 1.6 into the power minus, say how it is 6, just a minute. Minus 12, 12 Microampere. Ampere is coming. Second time. Into the minus 19. Time is 2 second. Direction of the current is time 2 seconds. No, there will be not the minus 6. This should be just 1 minute, students. This question is actually wrongly set. Sorry for that. This would be 10 to the power minus 12. Okay, the power minus 12. Okay, so this is the answer. Now let's go to the next question. Okay, in which material electric current develops when electric field is applied? Conductor में, wooden piece में, non-conductor. Answer is conductor, definitely. Let us go to the next questions. Okay, so next question is, in which conductor positive and negative charge both can move? Options are, the option is electrolytic solution. Okay, no need to explain, I think. Now the next question, the current in a wire varies with time according to the equation this. I to the 4 plus 2, there is variable current. It is varying with the time, where I is in ampere and T is in second. The quantity of charge which passes through a cross section of the wire T equal to 2 second and T equal to 6 second is. Options are these. Now you need to understand this calculation also. Here you see the time is given. Okay, current in a wire, suppose this is a wire, ये करंट जब इधर से पास होता है आई वेरिएबल, जो टाइम अगर सपोज 0, तब जो करंट है यार, द इक्वेशन इज आई इक्वल टू 4 प्लस 2t. इसका मतलब जब t इक्वल टू 0 करंट इज 4 एम्पियर. सो टाइम जैसे बढ़ता है तब करंट भी बढ़ते रहते हैं. नाउ दे हैव आस्क्ड व्हाट इज the quantity of charge which passes through a cross section of the wire in 2 second to 6 second. 2 second का सपोज इट इज 2 second to 6 second बीच में कितना चार्ज फ्लो हुआ है. Okay, now to find it out, we know that current I equal to dq by dt. That means charge by time is the current. So from I will to find out the charge. So dq equal to, I think, I dt. Okay, so here I equal to again 4 plus 2t. Here is dt. If I integrate it, okay, what is the time period? 0 to 2 to 6 second. So here dq would be q. Integration of dq is q. dq plus dq plus dq q. Now here you see I can write this 4 dt plus 2 to 4 2t dt. So it is coming like this. Q equal to 4t. Okay, 4t and Here it is 40 and it is coming 40, the limit 4 to 2 plus 2 t square by 2. Okay, limit 4. So on calculation, it is coming 48 coulomb. I think you will do this calculation. Okay, so answer is this. So hope this is clear to you. Okay, now see the answer. The answer. Yes, it is 48 coulomb, right? Now go to the next question. Two boys A and B are sitting at 2 points in a field. Both boys are sitting near assemblage of charges ball, each carrying charges plus 3 electron, 3e. A throws 100 balls per second through B towards B, and while B throws 50 balls per second towards A simultaneously. Find the current at the midpoint of A and B. Options are these. So here see, understand this. Suppose A is sitting here, B is sitting here. There is some few balls carrying charge 3e, carrying charge 3e. So A is throwing ball towards X, towards B, and B is throwing ball towards A. So A is throwing more number of balls. A is throwing 100 balls, okay, 100 balls. So 100 ball means how many charge? One ball carrying 3e. So total 3 charge. And B is throwing 50 balls. So he is throwing this kind of charge. So more charge. So net charge flowing. So net charge flowing would be towards B. That is 100 into 3e minus 50 into 3. Will be 50 into 3 charge is moved towards B. That means current will flow from B to A, because the net charge is flowing from A to B. So current will flow from B to A. So here you see, this is the possibilities of the answers. Now, what is the amount of current? So they're flowing it per second. Okay, this kind of charge is flowing per second. So current would be charge by time. So this is 50 into 3e by 1. So it is 150 into 1.6 into 10 to the power minus 19. So this would be, the value would be what? 16159 into 6 1 0 2 to be, just a minute, 3 e e, so e I emphasize 2 to e 6 2.4 into 20 the power to b. B is sitting both sitting on the A throws 100 balls per the B, and B throws 50 balls per second towards A. Okay, currents to B. So here you see the current is coming around 2.4 into 10 to the power minus 17 ampere. Okay, on calculation. So, but the direction is B to A. The current direction is B to A. How is it B to A? No, see, this is plus 3 charge. So these are not electron, these are proton. Okay, as these are proton, so current will be A to B. Got it? So this is not the correct answer. So current would be from A to B. Why? Because they have mentioned plus charge here. Plus means positive. So the current flows toward the positive charge flow. And you can say in the opposite of electron flow, electron is negative. So if proton is flowing in this direction, so current would be flowing A to B. And the amount of current is this. So option B is correct. Okay. So let us go forward. The answer, this is the answer. Okay. Now come to the next question, question number 29. In an hydrogen atom, an electron moves in an orbit of radius this meter with the speed of this. The equivalent current is. How to find out the equivalent current here? Okay. An hydrogen atom is moving. An hydrogen atom is an atom. Sorry, in an hydrogen atom, an electron moves in an orbit of radius atom. Speed of atom, the equivalent current is. So how can you calculate this current? Let us see. This is a hydrogen atom. Radius is 5 into 10 to the power minus 11 meter. Speed is given 2.2. Okay. So current here V is equal to 2.2 into 10 to the power minus 6 meter per second. Okay, and this is equal to R. Now we know current I equal to Q by T. Okay, now T is the time period. It is moving here like this. So I'll have to find out the time period. Time period T here is 2 pi R by V. Time period होता है ऐसे. Is it clear to you? Because it is moving with the speed. So 2 pi r is the 2 pi r. You can say capital R also. 2 pi r is the circumference of this, and so the distance table is 2 pi r. If I divide it by velocity, I will get the time. So on calculation, it is coming 2 into 3.14 into r is 5 into 10 to the power minus 11 divided by velocity is 2.2 into 10 to the power minus 6. So on calculation, it is coming around 1 point. It is coming 14.27 into 10 to the power minus 17 second. So if I put the value over here, I'm getting Q is 1.6 into 10 to the power minus 19 coulomb divided by 14.27 into 10 to the power minus 17. So finally, it's coming on calculation 1.12 into 10 to the power minus 5 ampere. Okay. So 10 to the power minus 5 into 10 to the power minus 3 ampere. So it is there 1.12 into 10 to the minus 3 ampere. This is the answer. So hope this is clear to you. Now we can go for the next question. Okay. Now just 1 minute. Just 1 minute. Just a little bit problem with the system. So bear with me. Yes, we are here. So here I've got the answer. This. So one question is remaining. So the question is, last question is, in a region 10 to the power 19 alpha particle and 10 to the power 19 photon moves to the left, while 10 to the power 19 electron moves to the right per second. Then the current is here the option. Here also the same concept as per previous one. See, this is right direction, this is left direction. So 10 to the power 19 particles moving in the left, and 10 to the power 19 moving in the left. Alpha particle 10 to the power 19 photon moves to the right. Okay, and again 10 to the power 9 electron moves to the right per second. Okay, see, in region 10 to the power 19 alpha particle and 10 to the power 19 photon move to the left, while 10 to the 19 electron move to the right per second. So current would be what? We know that one alpha particle means what? One alpha particle means equal to two charge, means two plus charge, means two photon. Okay, so if it is like this, alpha, this is the line. If it is A and this is B, so proton is moving in these directions and electron is moving in these directions. So what will happen? Definitely here the electrons are less number. Is it? 10 to the power 9 electrons are moving to the right per second, and alpha particle and the proton move to the left, while 10 to the power 9 electrons to the right second. So now you find out the current. See, the I, so current I would be 10 to the power 9 into 2.2 into 1.6 into 10 to the power 19 plus 10 to the power 19 into 1.6 into 10 to the power minus 19. Okay, charge. Here you see, this would be positive charge, this would be negative charge. Okay, so on calculation, is coming 6.4 ampere. So is it clear to you? Okay, no, not clear. See, this answer will be what? So the answer would be, I'm showing you, the answer would be, okay, let us clear this. Answer is 6.4 ampere towards left. Is it clear to you? Okay, so today, after this, Hope you find this video beneficial for you. So today is no more. I'll see you again in the next video. Bye bye.